Welcome to Lesson 18. As promised, at the end of Lesson 17, we are going to create a couple of bolts and screws using the coil feature, whereas in Lesson 17, we created some springs, created that solid geometry. As our part in this lesson, we are going to take some existing solid geometry and cut through it with the coil command in this first one, then add to it in the second example to create some threads. So let's start with a clean part. We will begin by creating the body of this first bolt. Let's create a sketch here on the XY plane. Come up here down below rectangle, we can draw a polygon. It is set to 6 sides for a hexagon. Sketch that hexagon, say OK. Now let's dimension it. Let's give this 0.4375, that is 7/16. You can also just go 7/16. That is 7/16 of an inch. For the head of our bolt, apply a horizontal constraint to that. So now that shape is fully defined, everything is constrained. Let's finish that sketch. Extrude that a distance of 3/16, which is 0.1875. Now we need to create the shank of our bolt. Sketch on the bottom face of that head, come to the center point and draw a circle. Let's give it a dimension of 0.250, 1/4 inch diameter. Now finish this sketch and we will extrude that circle out 1 inch. Let's put a little chamfer on the end of this. Let's make that 50 thousandths. And then we will put a fillet under the head. Let's make that 40 thousandths. Now we are ready to start creating the thread. So to do that, we need a sketch. Let's put this sketch, come over here to the origin. Look for a plane that cuts through the part. We have the XZ plane cutting right through the part, so click on that. And come in here, let's hit F7 to slice through the part. Now to create the profile of the threads, let's just come in here and draw a triangle. It is that triangle that will cut our threads. But we need something to attach it to. So come up and click Project Geometry. Get the edge of the side of the body there. And get the edge of the head. Now we have some geometry to work with. Let's create one more line through here. I want a line that falls on the edge of that body. So that now has stuck, but the rest of this is still free to move around. So let's continue to define the shape of this thread. A standard thread is 60 degrees, so add a dimension in here of 60. Put a dimension on that line that we created. Let's make that 40 thousandths. The pitch of this thread is going to be, it's going to be 20 threads per inch, which would be 50 thousandths of an inch per thread, but we don't want it to come to perfectly sharp corners. So for now, let's leave that at 40 thousandths. Let's add another dimension. Come on here and pick the endpoint. We'll dimension from the underside of the head, that line we projected, to the endpoint of this line and make it 20 thousandths. Add another dimension just so the top edge of this triangle is constrained at 20 thousandths. Now if you see, one more issue that we have is this triangle gets skewed. It is free to jump around. We need some way to ensure that our threads are centered up. We have the same angle on each side. One way to do that, we could apply a horizontal constraint from this vertex of this triangle. Come in here and pick up the center point of that line or the center point of that line. And now that has straightened up our triangle. Everything has turned black. It is fully constrained. And we can finish that sketch. So now we can see our triangle sticking out of the part there, and we are ready to coil as we did before. Go in here and click both of those profiles. It's going to cut just a little bit out of that fillet. Now see here, we need the axis. In the previous examples when we were creating those springs, we drew the axis. A coil has to have some kind of axis to work around. And in those previous sketches, we drew the axis as part of our sketch. Here we're going to select an axis and come up here under the origin folder. In this case, it is the Z-axis. We want the axis that cuts down through the center of the part. So we click on the Z-axis, and we can see the preview of the path of that coil cutting through the part. We want to make sure we are set to cut down here. Our body of our screw we made 1 inch long, and we're starting a little bit off that face. So if we put this at 1 inch, you can see that we're going to end up cutting off the end of the part, and that's fine. We're not going to create any unwanted geometry out there. We just ensure that we cut all the way off the end. So when we say OK and we cut, now we have a thread down the length of this screw. We see it taper out to nothing here with the chamfer that we put on the end of the screw. Now let's take a look at one more thing, just a little extra tip to help clean this up. Notice this flat face in here. If we were cutting this thread into this bolt, we would not end up with that flat face. I'm going to come in here and create a sketch on that face. Use project geometry to capture that whole profile. We have the complete outline now. So we can say OK, can finish that sketch and click extrude. So it will take that profile. Let's turn to cut. Tell it to cut through all, and now that cleaned that up a little bit. Keep in mind, this is not an engineering lesson on how to design bolts and screws. It is more of a lesson on how to use the tools within Inventor, but that is one way that we have there to clean up that little part and make it look more like a real bolt. You can save that one as lesson 18A. And we can start a new part that will become lesson 18B, another standard part. Let's start another sketch. Put our sketch on the XY plane. This time, let's draw the body, the shank of this bolt first. Let's make it a 3/8 diameter. Finish that sketch, and we will extrude it out. Let's make this one 1.25 inches long. None of this matters. You can play with whatever numbers you want. But let's put then the hex head on here. Sketch on the center. Drag our hexagon out there. Give it a horizontal constraint and apply a dimension. Let's make this one 5/8, 0.625. Finish that 2D sketch. Extrude. Selecting that profile for us. It's using the number that was previously there, but let's change that to 0.25 1/4 inch. Now we have the basic body of this screw. Let's add another chamfer as we did before down at the bottom here and make that 60 thousandths this time. Alright, so there's a basic body to begin with. So let's come in here now, pick a plane, cuts through the body of that screw, start a new sketch on there, and let's come in and sketch the profile of the thread we want to create. Let's project geometry again, get that edge. Let's change that. Click on that line, change it to construction geometry. Click on that. We want to be sure that don't use that. We didn't do that in the previous example, but it doesn't hurt sometimes to just turn it to construction geometry because we know we're not going to use it to create a solid. Start a new line, come down here to the end, and sketch in our triangle. So there is our triangle. Let's give this one a 50-degree angle, and again we will use that horizontal constraint. Oops, it gave me an error message because I already had a line selected. With nothing selected, we use a horizontal constraint to come out here and get that endpoint, make it horizontal to the midpoint of that line, And now we need one more dimension to finish defining this triangle. So let's add a dimension here from that point. Let's see if it'll, we don't need the endpoint, we can use that line. Let's make that 30 thousandths. Now we have our little triangle down here that is going to form the thread as we coil around this part. We can finish that sketch. And now we are ready to create our coil feature. So come up here and click on coil. For this one, let's use the option of pitch and revolution. Let's use a pitch of 80 thousandths. That will put 80 thousandths spacing between each thread. And let's look at how to figure out how many revolutions we're going to need. We know that this is 1.25 inches long. If we divide that by 0.080, divide by 80 thousandths, be sure we are down here to add material. We need to pick our axis, the XZ plane. There we go. Now we have our preview, and see how it gives us a thread coming off the end of the part. So let's go back here and edit. What if we do this? Math is nice to help us out. -1. Let's stop one thread short. We're still getting down here into our chamfer. Let's make that -2. Yeah, we could do math on our own, but it's nice when Inventor does it for you. Let's see what that looks like. We come down here and we stop short of the end, and that is fine. That comes to a blunt end right there. Now, if you remember in the other part, we had that kind of taper down into nothing on the end of that chamfer because we were cutting into that. But we don't have that here, so let's do something a little bit different. Let's use another coil. Let's start another sketch on that face. Let's zoom around. Use project geometry to get that full profile. So now we have the shape of our thread again. Finish that 2D sketch. Go back up here again to coil. Again, it is selecting that profile. We want the Z-axis again, and see it starts. It gives us the preview here with the numbers that we had in there before. Let's keep our 80 thousandths pitch. Let's try 2 revolutions. Let's make it 1.5. That'll get us just to the end. But this time, let's taper. Let's see what a -10 degrees looks like. See, it starts to disappear, but we're coming out the end of the part. Let's make that -15. See what happens if we just do 1 revolution. I think this is going to work. It's going to taper into the part. It's going to finish there. I still have a little bit of a blunt end. Let's go and let's make that -20. A little further. Let's go negative. What if we get -30? There, that gives us something. That tapers down into a sharp point. Looks a little bit more realistic. This just shows you how you can work with these numbers. This just shows you how you can work with these numbers to try to get the result that you want. You don't have to know all of the exact numbers, everything the first time. Yes, I could go along and do this and have the numbers prepared. That would give us the exact perfect result. But this shows that we can play around a little bit, that we can work with it. We could come back in here. What if we make this coil? Let's take another one off of there. Let's make that -3. And we stop a little bit shorter. Then we come down here. We give that 2 revolutions, maybe -20 degree taper. And we see the result that we get. It fades in a little sooner than we want it to. Let's make it -15. -15 takes it out a little bit further to the edge. Again, play with the numbers, work with it, experiment, just to see what different results you can get out of it. All right, well, that is it for coil. We have created springs. We have added threads by cutting material. We have added threads by adding more material. Continue to work with the coil command, experiment with what's there, and then come back in lesson 19 and we'll learn something new.